Suppose you already have a great OT asset management system. It automatically discovers the identity and configuration of your PLCs, RTUs, network switches, operator stations, and so forth. Your engineers use the system as their central hub for documenting the company's OT infrastructure by attaching tags, documents, and other metadata to individual devices, networks, and distributed control systems. Could you ask for anything more? Certainly. You determine that such an OT management system would deliver even more value if it would integrate with enterprise software such as ITC MDBs, service management applications, and even custom-built apps. You would want all of these being able to access the information in the OT asset management system. This is exactly what you can do with the REST API in the OTbase asset management platform. But before explaining how, let's work through the terminology. An API is an application program interface, which simply means that data can be accessed by software processes rather than only by humans. On one side of the API, you have a server process, in our case the OTbase asset management platform, and on the other side a client process, which can be ServiceNow, for example. APIs used to be proprietary, arcane, and cumbersome, but web technology has changed the landscape completely. The undisputed standard for exchanging data between web applications is the REST interface, which is an acronym for Representational State Transfer. The important thing about REST is that it uses the HTTP protocol that all your web applications speak anyway. If you have ever taken a closer look at HTTP, you will know that every time you load a web page from the internet, your browser issues an HTTP GET request to the server identified in the URL. In REST, HTTP GET is used as well, but rather than returning HTML information for fancy display, the server returns data items in the JSON format. JSON is an acronym for JavaScript Object Notation and has become the predominant data format of the internet. The best thing about JSON is that while it is intended to be consumed by automated software processes, it's still human readable, as you will see in the examples that follow. As a regular user, you access OTbase by entering the URL of the server where your OTbase Asset Center is running in your browser. The OTbase server will then respond with the HTML code for the specific view that you have requested. After logging in, you can browse your asset inventory and also drill down into the details. All this looks nice for the human user, but for an automated software application it isn't really useful. For accessing the REST API in OTbase, we use the same URL, but append it with /API /v1 for version 1, and also tell OTbase the specific resource that we want to access. As an example, we can access the hardware inventory by specifying devices. And just press enter. OTbase now prompts for an authentication. And this is your output. Certainly very much different from the HTML code that you saw earlier. So what you see here now is the JSON format, which is already filtered by a Google extension that I'm using. It is the JSON formatter. If you want to see the raw data, it would look like this. And the JSON extension simply prints it out so that it makes more sense for a human reader, and then you can collapse and expand the various sections. Guess what? We have just made the first call to the REST API in OTbase, and the results look pretty promising. However, the browser is probably the most inefficient tool if you really want to start working with REST. For our next examples, we will use the Postman application to see how it works. Postman is a popular tool for testing REST APIs that you can download from getpostman.com. So again, let's retrieve our asset data from OTbase by issuing a GET request for the devices resource. Also notice that we have provided authentication data that Postman will automatically send to OTbase, so no interactive login will be required. And if we press send, then we will see the response of the OTbase Asset Center down here. If I am only interested in the configuration data of one specific device, I can specify the device identifier of that device after the device resource in the URI and issue the GET request. But there is even more asset data that I can access. For example, I can export all the software applications and security patches installed on a given computer that is monitored by the OTbase Asset Discovery engine. Because this list can get pretty long, software data is not delivered with each device query, but requires me to address it as a separate resource. This is achieved by simply appending software to an asset resource. In the next example, we obtain the list of installed software of a computer identified as OpStation 1. As a last example, we want to export all the I/O modules of a specific RTU identified as lu.bk12. All we need to do is append /modules to the resource identifier of the RTU and issue the GET request. And there we go. Again, the information that we see here was automatically discovered by OTbase Asset Discovery and is now available to your enterprise software. The REST API in OTbase allows your enterprise applications to break through the OT barrier and consolidate workflows such as service management, lifecycle management, and vulnerability management. To learn more about the OTbase Asset Management Platform, check langner.com/OTbase.